Okay. Chandler wants to answer. What do you think the correct answer is? D is correct. Now let's talk about y. It says find the value of the greater root. Well, just a minute ago we talked about what a root is. A root is the same thing as an x-intercept. And remember, they're also called zeros. So all you would have to do is graph this, x squared minus 6x plus 5, x squared minus 6x plus 5. Tyler, turn around. Once you've graphed it, you look at the x-intercepts. And where are the x-intercepts located? 1 and 5. And out of the two, the greater one is the 5. So it's D. Pretty easy, right? It's easy as long as you understand what the word root means. You have to know that that's an x-intercept. Zero is also another word they'll use for x-intercept. Okay, now turn in your packet to page 3. Nope. Page 3. Ethan, turn around. Number 5. What is the A value here? No. 1. Remember, the B value is always the number that is raised to the exponent. So the B value is 2. So if there's nothing in front of that, that means the A value is 1 and they just didn't write it. Since the B value is 2, does that mean this is a growth or a decay? Growth. And remember, a growth goes up from left to right. Now, are there any kind of shifts that are going to occur, horizontal or vertical? Well, no, remember, if the number is added or subtracted on with the exponent, it's a horizontal shift. And when it's horizontal, it's always opposite of what you would think. X plus 1 actually shifts it left 1. Okay, now, I don't know if you remember this from yesterday, but where is the y-intercept originally? 1. But if every single point on this curve is getting shifted left 1, won't that mean the y-intercept is going to leave the y-axis and now be right here? And so it's no longer the y-intercept. But we now know that there's definitely a point at negative 1, 1. Does anybody know where the asymptote line is? No. 0. Okay, it always starts at y equals 0. And if no vertical shifting has occurred, like it hasn't moved up or down, then it will remain at 0. Okay, so your asymptote equation is y equals 0 because it cuts through the y-axis at 0. Now, to actually put the rest of the points on this graph, what do we need to do? Graph it on the calculator. So go to your calculator and type in y equals and then 2 raised to the x plus 1. So first hit y equals, and then after that type in 2 and then raise to the x plus 1, and make sure that plus 1 is little, like the exponent. Once you've done that, graph it. Okay, and we are right, it is a growth. Okay, it does flatten out right here at 0 because the asymptote's at y equals 0. But to find the actual points, we need to do what? Go to the table. So if you hit second, then graph, above it is the word table, and it'll take you to the table, which gives you every point on that curve. Okay, now where is the y-intercept? Right, when x is 0, isn't that number the y-intercept? So your y-intercept is 0, 2, so I'm going to go and plot it, and I'm going to go ahead and write it down here because they ask about it. Okay, some other points that I could plot are 1, 4. So right 1, up 4. And then after that, 2, 8. So right 2, up 8. And then the next point on that side of the x-axis is 3, 16. Well, is that going to fit? Can we plot 3, 16? No. We can go right 3, but if we try to go up 16, we'll run off the graph a good bit. So now we're going to plot some points on the negative side. Well, the first one is negative 1, 1. Well, look, I already have that point because wasn't that originally the y-intercept before it got shifted left? So now let's plot negative 2, 0.5. So left 2, up a half. And then after that, negative 3 up 0.25 would be like right here. And let me zoom in so it's a teeny bit easier to graph them. Okay, but after that, can't you see that the further you go left, like negative 4, negative 5, negative 6, all of these numbers are getting closer and closer to what value? 0, because that's where the asymptote line is. And so since it's pretty much impossible to get these in the exact correct place, I just pretty much put points right along the top of the x-axis. Well, because you can see that it's flattening out at 0, and also the asymptote always begins at y equals 0, and if there's no vertical shifts up or down, that's where it will remain. Okay, it will always start at y equals 0 for all exponentials, and it will only move if there's a vertical shift, like if there's a big plus something or minus something added onto the end. Okay? All right, now that we have a sketch, we can answer the rest of these questions. What is the domain? Correct. Doesn't it go left forever, and as it's going up, it's also slightly moving out right forever? And that's the domain for all exponential functions. They all go left and right forever, no matter if they're a growth or decay. The range is the one that will change from problem to problem, and why is that? What's it affected by? The asymptote line. So this time, how low will the curve go? 0, where the asymptote is. It's a barrier, and you cannot go below it. How high will the graph go? Positive infinity. Now remember, for end behavior on this Friday's quiz, it's going to be written like this. Yep. As x approaches positive and negative infinity, and then they'll have the words left and right, which is really, guys, the words left and right is what this means. X approaches positive infinity means right, x approaches negative infinity means left. They want to know what the y's are approaching as you go left and right. So when you go to the left side of the curve over here, all of these y values, every point would have a y value getting closer and closer to what? 0, the asymptote. And if you go over here to the right side of the curve, every point over here has y values that are getting higher and higher forever, so infinity. Any questions about that? All right, let's go over to number 6. Is everybody finished copying number 5? Everybody good now? Yes. All right, number 6. For number 6, what is the A value? 1. There's an understood 1 out here in the A place. What is the B value? 3. Which means this is a growth or a decay? A growth. Anytime your B value is greater than 1, it's a growth. So it'll go up from left to right. Because it's growing, it's tripling, so it's growing. Like if this were a real life scenario with a word problem, it's tripling, which means it's growing. Okay, so if you're talking about like a population, populations can be represented by exponential equations because they grow exponentially. They normally don't grow linear. They don't grow at the same rate every year, do they? There's like booms in populations. Chandler, turn around and pay attention. Turn around and pay attention. Okay, are there any shifts that occur to this exponential function? No, actually, remember, whenever it's a horizontal shift, it's opposite of what your common sense tries to tell you. X minus 2 is actually right 2. Remember with parabolas, when it was x minus h, that moved it right, and when it was x plus h, it moved left? It's because the formula already had the minus in it. And so if it became plus, that means it was minus a negative, which moved it left. Okay, so it's right 2, and then what does the big plus 2 do to it? Up 2. Okay, Amari, where is the y-intercept originally? Yes. No, a equals 1, so the y-intercept's at 1. but it won't stay there because everything is getting shifted right to and up to. So now that y-intercept is no longer a y-intercept because it's been moved over to and up to, so now it's at 2, 3. That'll be one of the points on your table once you've graphed this. Now, the asymptote always begins at where? 0, but now it's going to be shifted up 2. So now the asymptote line is going to be up here at y equals 2. It's going to cut through the y-axis at 2. So y equals 2 is the equation of the asymptote line. Now to get the rest of the points for this curve, what do? Graph it. So go to your calculator and graph that. Y equals 3 raised to the x minus 2, and then arrow over to come back down before putting plus 2, and then graph it. Plus 2. 3 raised to the x minus 2, and then a big plus 2. Okay, once it's graphed, to get the points, and before we even go to the table, can't you see that it is flattening out at 2? And so that confirms that we're right about the asymptote being at y equals 2. And it's definitely a growth because your b value is 3. And anytime the b value is greater than 1, it's a growth. To find the points, you go second graph, which will take you to the table. Now, you can see on the left side, as you go into the negatives on the left, they're all getting closer and closer to 2 because that's where the asymptote is. On the right side, it's 1, 2.3, 2, 3, 3, 5, and then let me go down to 4 to see if I can plot it. I can't. What is it? 11. So I could do it, I mean, because that's not very far off the graph. Where is the y-intercept? 2.1. Okay, see, when x is 0, that means it hasn't moved left or right. It only moves up 2.1. And if it only moves up or down, it's sitting on the x-axis. Now, that is so close to the asymptote that you pretty much just need to draw it like right on top of it. So there's your y-intercept, and then go ahead and write it, 0, 2.1. Okay, another point that I could plot is 1, 2.3. That'd be right 1 up 2 1/3, so like maybe right there. And then another point I could plot is 2, 3, which is right 2 up 3. Why do I already have that point? What? How do I already have this point? Right, that was originally the y-intercept before it was shifted right 2 and up 2. Okay? All right, then I can also plot 3, 5, which is right 3 up 5, and then 4, 11. I mean, I can pretty much do that because even though mine only goes to 10, there's little lines up there. Okay, so that's what the right side of this exponential curve looks like. Now let's look at the left side. Negative 1, 2.037. That's already so small and so close to 0 that I'm not even going to attempt to get it in the right place. I'm just going to put them right along the asymptote and then draw the line, or the curve really. Okay, so what is the domain? Correct. All exponential equations have this same domain. They all go left forever, and as they're going up or down, they all go right forever. The range changes because the asymptote can change. This time, what's the range? Well, just the y-intercept is 2.1, but isn't the asymptote exactly 2? So 2 to infinity. Because look, some of the points went below 2.1. This one's 2.0002. Okay, so the asymptote's at 2, so you go from 2 to infinity. And then for end behavior, if you're on the left side of that curve, all the y values of all those points are getting closer to what? 2, the asymptote line. If you're on the right side, all the y values of the points are getting higher and higher and higher forever, so infinity. Does that make sense? Okay, everybody finished copying it? Okay, let's look down at number 7 then if everybody's finished copying it. Nobody wants to speak up and say I'm still copying? Okay. Well, I still see people writing. Maybe they're going ahead. All right, number 7. This one's different, so I would pay attention. I would not go ahead. You're not having homework anyway, so there's no point in going ahead.
No.
What is the A value? -1. Remember, even though the negative is beside the 2, we talked about this yesterday, can B ever be negative? No. Remember, B is either greater than 1, and that's the growth, or B is less than 1 but greater than 0, and that's the decay. It will never be negative. So if there's a negative out front, it belongs to the A. There's a -1 in the A place. And then the B is 2. So Chandler, what does that make this? A growth. Okay, where is the asymptote? No, the asymptote. Yeah, I'm asking you. Right, and was it shifted up or down? So it stays at 0. Where is the y-intercept? -1. And have, because the asymptote is always at 0. The only reason it moves is because, like in the previous problem, there was this +2 on the end that caused the entire asymptote line to be shifted up 2. So vertical shifts will move the asymptote. If there are no vertical shifts, the asymptote will remain at y = 0. Yes, Henry? We're going to talk about that. Okay, look. Now, the y-intercept is whatever the A value is, -1. And have there been any horizontal or vertical shifts? So the y-intercept will remain at -1. So we can go ahead and write in some stuff. We can go ahead and write in that the y-intercept's at 0, -1, and the asymptote equation is at y = 0, because it's a line that cuts through the y-axis at 0. Now, when you graph it, we're expecting a growth, so we're expecting this. But go ahead and graph it and see what happens. It's not a decay. Very good. It's an upside down growth. Because remember, if your A value is negative, it's a growth, but it's a growth that becomes reflected, so it looks like that instead of that. Does that make sense? Okay, now we already have the y-intercept. Let's get some other points by going to the table. So second table, I can plot 0, -1. I already did. That's my y-intercept. I can plot 1, -2, which is right 1, down 2. I can plot 2, -4, right 2, down 4. I can plot 3, -8, right 3, down 8. And then after that, the next one was 4, -16, and that won't fit. So now I need to plot some points on the other side, like -1, -0.5 would be left 1, down 1/2. And then -2, -0.25 would be left 2, down 1/4. And then after that, they're getting so close to 0 that you're not going to be able to plot them exactly right, so you'd pretty much just put a little point right below the asymptote line. Okay, and so the curve ends up looking like this. Or more or less. Okay, so does everybody understand why it now looks like that, even though it was a growth? It's a growth that has been reflected because the A was negative, which put your y-intercept over here. Okay, what is the domain? Right, even though it's reflected, it still will go left forever, and as it's going down, isn't it also slowly moving out to the right? So negative to positive infinity. What is the range now? Nope. It'll be negative infinity because it goes down forever up to 0. You've got to remember that for domain and range, it's always negative to positive. Okay, domain and range are negative to positive. So for domain, that's left to right. For range, negative to positive would be down to up. Because left and down are negative, right and up are positive. Does everybody understand that? Yep, and range is down to up because you always want to go negative then positive. So left, right is negative then positive. Down, up is negative then positive. Okay, in behavior. On the left side of this curve, all the y values are getting closer to what? No. 0, the asymptote. On the right side of the curve, Chandler, pay attention, all the y values are going down forever. They're getting lower and lower, so negative infinity. Okay, we're going to start doing some skipping around so I can cover everything I need to. So go to page 5. Friday, it's a quiz, 10 questions. Yeah. All right, page 5, here we go. Shh, calm down. All right, number 1, the directions say identify the A and the B value, growth or decay, and list the following characteristics: domain, range, y-intercept, asymptote, and end behavior. So basically what we were just doing, except you're not going to have to what? Graph it. You're just going to be able to put it into your calculator and answer all the questions from there. So what is the A value? 2. The B value is 1/3. So is this a growth or a decay? Y'all, the B value is 1/3, which is less than 1, so decay. So that means the graph's going to look like this. Is it going to get reflected or stay looking like that? It's going to stay like that. The only reason it would be reflected if what happens? If the A were negative, it would reflect, but the A is not negative, so it will stay like this. Now, it doesn't say so in the directions, but I want you to also list if there's any shifts. Do any shifts occur here? No. So now let's get ready to write those characteristics. So just write out D for domain, R for range, y-intercept, asymptote, and EB for end behavior. Go ahead and write those out. EB. Yep. Okay, so we can answer some of these questions before even graphing it. Which ones can you give me an answer for before graphing it? Okay, where's the asymptote? Right, y equals 0 because why? How do you know that it hasn't been moved? Correct, there's no vertical shifts. Okay, what else can you tell me since there's no shifting? What's the y-intercept? No, it's not 1, it's 2. The A value is the original y-intercept, and it will stay that if no shifts occur. And since nothing was added or subtracted to the x or to the end of the equation, that means no shifts occur. And what else can you tell me without even graphing it? Domain, because the domain is the same for all exponentials. What is it? Correct. They will all go left forever and right forever. Now, don't we just need to see a picture to do the range and the end behavior? Okay, so graph it. Y equals 2 times, hold on, mine's froze. Go ahead and graph it yourself. Down to up. How far down the graph goes, how far up the graph goes. Yeah? Hold on 1 second, let me reset this. Alpha y equals n over d. I really hope y'all realize that no teacher will be able to tell you how to do any of this on the EOC day. No, I won't. I won't even be in the room with you. No. It's a very slim chance that I would be with your class because all Algebra 1 students take their EOC at the same time. Well, I have 5 Algebra 1 classes, so you got a 20% chance that I'm going to be the teacher with you. I mean, it might happen, but it's only a 20% chance that I'm going to end up with third period testing that day.
That's 1 out of 5.
Very good. Okay. How do you think I knew 20%? I said, you're 1 out of my 5 classes. Okay, so now let's graph it. Y equals 2. Now listen, if you don't want to use alpha y equals n over d, you don't have to here. Once you open up the parenthesis, you could just type in 1 divided by 3. But you have to have parentheses, otherwise it'll be wrong. Otherwise, it'll look like 21 divided by 3. Okay, and then raised to the x power. You can use alpha y equals and do 1 over 3, yeah. Okay, once it's graphed, we can answer these other questions that remain. Okay, so here's a picture. What is the range of that? How low does a curve go? 0 is the lowest. Do you ever see that blue go below 0? No. So that's as low, and why can it not go below? That's the asymptote. How high does the blue curve go? Forever. So the range is 0 to infinity. Okay, and then for end behavior, left and then right is how it will be written out on your quiz. And you will just have to know what to put for the y's. On the left side, it's going up to infinity, and on the right side, it's going to 0. Does that make sense? Yeah, on the right side, plus guys, look. Once you have a rough sketch like I did already, and you know the asymptote's at 0, can't you pretty much just use this as your picture instead of having using a calculator at all? You can see that the left side goes up forever, the right side is what flattens out at the asymptote, and you already told me it was 0. Because it always starts at y equals 0, and if you haven't added anything to the end, like, no, k, like if there's a plus 2 at the end in the k place, that'll move the asymptote up 2. Okay, let's try number 3. Go down to number 3. Shh, focus. What's the a value? I don't see a negative. Are you on number 3? 1/4. Chandler, turn around or you're going to have to go sit outside. B is 1/7. I am trying to teach. Is this a growth or a decay? Decay. Okay, so it's a decay which goes down from left to right. Will it stay like that or will it be reflected? It'll stay because your A value is positive. So you know this is what it's going to look like on the calculator screen. Now, for the domain, don't we know for any exponential function, the domain is all real numbers, negative to positive infinity? And then, where is the asymptote? Y equals 0, because that's where it always begins. And if you haven't shifted it vertically up or down, that's where it will stay. So I pretty much know right here is y equals 0. Okay, what's the y-intercept? The a value is the y-intercept, so 0, 1/4. And since it's not shifted left or right, that's where it will remain. Okay, end behavior. Without even doing it on the calculator, I can just look up at my little sketch. On the left side, it's doing what? Going up forever. And on the right side, isn't the right side the one approaching the asymptote? And where do we say the asymptote is? 0. And then on the range, how far down does it go? 0, where the asymptote is. How far up does it go? Infinity. Okay, now turn to page 7. Okay, everybody turn to page 7. I'm giving people time to finish copying this first. No, we're almost done. Tomorrow I'm not teaching anything new. Thursday I'm teaching the last thing, and Friday's the quiz. No, tomorrow you're just practicing. Okay, can I move on now? Okay, make sure you're on page 7. Okay, on page 7, you've got to do the average rate of change between the 2 points. So we have an exponential curve, and the points have already been labeled for you. Average rate of change is the same thing as what? Slope. So all they're asking you to do here is find the slope. When you have a graph, what's the easiest way to find the slope? Count the rise over run. And you always go from the left point to the right point. So to get from here down to here, don't you have to go down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So that's down 15. No, you always go from the left point to the right point. Okay, then you have to go over how many units? 2. Plus, listen, if you don't get a negative for this, you know you're wrong because isn't this a decay? It's going down. So it should be a negative average rate of change. You don't have to. You can leave it as a rise over run. Okay, so now let's look at number 2. Just by seeing that it's a decay, we already know that the average rate of change is going to be negative, right? But this time you're going from this point to this point, and that's down 1, 2, 3, 4 over 1. Now, Amari, they're not the same thing because look, this B is 1/2 and this B is 1/3. And so they both are decays, but they're not the same thing. Okay, number 3. This time, you know your average rate of change has to be what kind of number? Positive, because it's a growth. So if we go from the left point, which is right here at the y-intercept, up to the point up here, that's up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So rise 15, run 2. So it's an average rate of change of 15 over 2. No, they've given you the points. No, this one's a growth, so it's positive because it's going up. Yeah. Okay? Just like with a linear equation, lines that are going up have positive slope, lines that are going down have negative slope. Number 4, try this one by yourself. You already do it? Because you have to start from this point, which is at 1, and go to this point, which is at 16. That's a rise of 15, and then a run from -2 to +2 is 4 units. Okay, look back through pages 3 through 8 and tell me which ones you still feel like we could practice some more, because we still have 6 minutes. Pages 3 through 8, like pick a problem that you think you could use more practice on pages 3 through 8. There's no problems on page 4 that you think you need me to work for you? Number 8 on page 3. Okay, go to page 3. Shh. Please stop talking while I'm teaching. It's rude. Okay, page 3, number 8. This will be the last problem, and then we'll be done for the day. Page 3, number 8. No, we did everyone but that one. Okay, number 8. What is the A value? What is the B value? Which means this is a decay, but, right, it is a decay because your B value is less than 1, but since the A, it's going to be reflected and it'll end up looking like that on the graph instead of this. Okay, so where's the y-intercept? Okay, does it shift anywhere? No, because nothing's been added or subtracted here, so there's no horizontal shift, and nothing has been added or subtracted to the end, so there's no vertical shift. Where is the asymptote line? Right, and since there's no vertical shift, it will remain at 0. So we've already answered 2 questions below by just knowing the rules of the equation. The y-intercept is at 0, -3, and the asymptote line is at y equals 0. And then we also know what about all exponentials? Shh. Their domain is what? -infinity to +infinity. Okay, you quickly graph this and find me some more points to plot. down to up. Your domain and range, stop, always go negative to positive. Well, negative to positive on the x-axis is left to right. Negative to positive on the y-axis is down to up. Because think about it, the y-axis, down is the negative numbers, up is the positive numbers. No, I'm waiting for y'all to graph it and give me some points. Stop being lazy. No, real points. There's no way there's a point at 0, 3 because this is going to all be below. Okay, well, -1, -6 is good. Oh, let me change the color. You need to stop talking and stop packing up while I'm teaching. People are trying to learn. And then we can plot one at 1, -1.5. And then 2, -0.75. And then after that, you can see that they're all getting closer and closer to the asymptote line of 0, right? So it looks like this. Okay, so what is the range this time? Negative infinity, because it goes down forever, up to 0. When you go to the left side, the y values are all approaching negative infinity. On the left side, they're all going down forever, and on the right side, they're approaching 0. Listen.